All right, guys. So let's work on this deck of cards assignment. I'm on my desktop, and if I were you guys, I would probably initialize this project in some type of folder structure that you guys have. But I'm just going to do it on my desktop. I'm going to make a directory called deck of cards, cd into deck of cards, and I'm going to .NET new. For some of you, .NET new console. Cool. So I created a new C# project. If I open this guy up in VS Code, I should see a couple of files, my project.json and my program.cs, which are right there. So yes, build my debug tools, and yes, restore. Cool. So program.cs, awesome. Good to go. Let's give it a run just to see if it's working. So go to my terminal, .NET run. Hopefully I'll see hello world. All right, hello world. Is that good for everyone to see? Yeah? Okay, cool. All right, so this assignment I think is laid out super well. It just kind of gives you one task at a time. Do this, do this, do this, do this, and you can just like check them off one at a time. And before you know it, you have like a full deck of cards, and you're like maybe like 5 or 6 methods away from like a fully functional card game, and it's pretty cool. So let's take a look at what our prompt is. I'm gonna move this closer. And I'm just going to go through it one at a time and literally do what it tells me to do. So the first thing it tells me to do, it says create a class called card, right? So in order to create a new class, why does it keep doing that? I'm going to, I think someone asked earlier in lecture today if it's okay to have multiple classes in the same file. It's okay, but not recommended. So I'm going to create a new file called card.cs. Inside card, I'm going to create a new class, but first let's give it a more descriptive namespace. Let's say I'm going to eventually turn this into blackjack or something. So blackjack, in my card.cs, share the namespace of blackjack. I'm going to have a public class card. Cool, so I did that. First one's checked off. Give the card class a property string val, which will eventually hold ace through king, and it should be a string. Give the card a property suit, which will hold the suit, and of course it'll be a string. Give the card a property val, which will hold a numerical val. Why do you guys imagine we have a numerical value tied to each card object?
So that we can evaluate it as it, rather than you can't compare ace to king as a string.
Totally, exactly right. So eventually when we do turn this into a game, we're going to want to compare cards against each other. So that's exactly why. Yeah, cool. So public string string val, I think they called it. And public string suit, public int val. And second one's checked off. Cool. Or the entire first section's checked off. Any questions so far?
Could you do that again but without doing getting inside?
Yeah, we don't need these. Well,
What are those for?
I'm going to err on the safe side and say that this is good, good practice to just explicitly state that these have getter and setter methods, so that we can, someone coming into your code can see, oh, okay, I can set string val and I can get string val, right? They're public variables, so they are freely gettable and settable. Now, if they were private, then you may want to have like a get method specified so that maybe we can get the suit of a specific card, but we can't manually just set it from the outside. Like, oh, set this suit card to a heart so I have a full house, right? Or I guess suits don't matter in full houses. A straight flush, I don't know. So maybe you guys might want to do that, and if you want to do that, then you can manually just define them by setting the value of them, or by reading the values from them. But again, going back to what I was saying, they're public, so they're not by any means necessary, but just good practice to have them. give that a sec. All right, while that loads, let's read the next prompt. Next, create a class called Deck. Give the Deck class a property called Cards, which will eventually hold a list of card objects. That's interesting. So we'll get back to that. It looks like this thing loaded. So down here, we briefly mentioned getters and setters. For the scope of what we're going to do for the next couple of days, they're not hugely important, so it's rather brief. But you can see here, we have a private variable called underscore num passengers, and we've initialized that to 5, right? And then we have a public int num passengers, which looks a lot like a method because of the way that it's structured, but really it's also just an attribute, and we're defining the get and set methods inside of this attribute, right? So the get method will return what's being stored in the private variable above, right? And for a second, imagine that this set line didn't exist, right? So imagine that line's gone. Then in that case, then we can properly retrieve variables that are being stored privately through this public attribute. Does that make sense? And this is more of how we would use it. If you have a getter and setter that's kind of retrieving these private attributes, then why not just create a public int num passenger, which is kind of what it points you to. Like if this is what you're doing, then just kind of set it standard like this. But if for whatever reason there's a variable which you want to store privately so no one from the outside can manipulate it, but may want to retrieve it, this is how you would do it. And a good example case for that is like your bank account like balance, right? You may want to retrieve your bank account to figure out how much money you have in there, but you wouldn't want somebody or maybe even yourself to be able to just set that number. Yeah, maybe you want to, right? The bank doesn't want you to, right? So in that case, you would have this like get method that returns to you the actual balance, but you wouldn't have a set method that allows you to set that balance. Does that make sense?
So in this example, you could set additional private attributes, and your setting and getting functions would not work on those because they're only designed to work on the initial private non-passengers.
Say that again?
So if you had additional attributes, let's say I had non-passengers 2 that were the children of non-passengers.
Okay.
Could you access the children, even if they were set private, through the public integer?
Public int num passengers? No, you would need to set getter and setter methods for that private variable.
Okay.
That attribute.
Yeah.
Every attribute is going to have their own set of getter and setter rights.
Okay.
Yeah, they're all independent from each other. Cool. Anyways, getting back to what we were talking about. So we're creating a deck class, and I'm going to give it a property called cards, which will be a list of card objects. Cool. So just like we created a card.cs, I'm going to create a deck.cs, namespace, blackjack, public class deck, was it? Cool. So I've created a deck class, and it's going to have a property called cards, which will hold a list of card objects. So list of card objects called cards is going to equal a new list of card. And why do you guys think I have some red squigglies here?
Because you have an imported card system.
Kind of, yes. We don't have everything we need, but it's not cards that we need because we have cards. They share the same namespace, so we have access to cards, but we don't have access to lists. Exactly. Yeah. Exactly. Cool. So we're just gonna use it. So once we have that using statement, everything's gravy. So we have a cards collection, which will eventually hold a list of card objects. Everyone good on that? This line can be very confusing. But if you understand that, okay, this is just you're typing what this variable is. What is this variable going to be? Well, a list of cards. Cool? Question? Yes, you're right. Thank you. Perfect. Cool. So We have a list of cards. When initializing the deck, make sure that it has a list of 52 unique cards as its cards property. Cool. So I will have a, so when initializing, that points me to, oh, okay, so I need a constructor function. So public deck, I have a constructor function. And my constructor function is going to probably call a function called like build deck, which I will define down here. So public build deck. I don't think this returns anything, does it? Nope, just going to do something. Public void build deck. Cool. So build deck is going to build me 52 unique cards and store them in my cards list, right? There are a number of ways that you can do this. Having seen all the students come through this class, there are like at least a couple of dozen different ways to do it. I'm just going to do it the most standard way, which is to use a couple of for loops that are going to go through your suits, and they're going to go through all of the different string values that you have, like ace through king, and then just build your card objects that way. It's very easy to see. So I will have a string array called suits, and I'm going to store in there, what are my suits?
Clubs, spades, hearts, and diamonds.
Clubs, spades, hearts, oops, yep, diamonds. Cool. And then I'll have a string array called vals, which will hold ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. Cool. So I have these two arrays of strings. I'm going to for loop through them for ints I equals 0, I is less than suits dot length, I plus plus, for int j equals 0, j is less than vals dot length, j plus plus, and then I will add my cards. Cool. So at this point, if I want to create a new card, I'm guessing I'm going to need a constructor function for my card also. So public card, I will pass in a suit. I will pass in a string val, and I will pass in an int for val. And when I do, I'm going to set suit to equal suit. I'm going to set string val equal to string val, and I'm going to set val equal to val.
Your string val is backwards.
You're right, it is. Oh, cool. All right, so now I can create cards just by passing these variables through. So I can, cards is my list. How do I add something to a list? Yep. So what am I adding to my list? A new card object. And my card object, if I hover over it, it needs a string suit, string val, and an int val. So my string suit will be suits of I. My string val is going to be vals of j. And my int val is going to be maybe like j plus 1, because that's kind of what I got going right now. J plus 1. Oops. Cool. So I'm going to create a whole bunch of cards. Hopefully this will do it for me. So let's instantiate a new let's play some blackjack. And let's put into my deck, my deck equals a new deck. Cool. So if I were to check out my deck and put a breakpoint on that, run it through my debug. Are we all using our debug tool? Yay! Love to hear it. Cool, it stops right there. I can check out my deck. When I check out my deck, so far so good. There's 52 things in there, right? Let's check out what those things are. Looks like they're a bunch of card objects. If I take a look at my first card object, it's a ace of clubs. If I look at my second one, it's a two of clubs, and so on and so forth. If I take a look at that, that's a king of clubs. Hopefully my nested for loop restarts and I get an ace of spades. Cool. Everyone clear on how I created my deck of cards? So we have two arrays, right? Just two hard-coded arrays, which in my opinion is perfectly fine. It's very space efficient. We know exactly how many cards there are going to be, right? 4 sets of, what is it, 12, 13? 13 cards, right? 4 sets of 13 cards, right? And that's every standard card set is 52 cards, right? So we have what we have, and we're just going to run a nested for loop through it. Nested for loop isn't too bad if you know exactly what data set you're getting. It's just n times m, which is 4 times 13, which is 52, right? So this is going to run exactly 52 times, and for each of those 52 times, or each of those times, it's going to add a new card. Basically, that's all that's happening, right? Cards.add a new card. This is going to pass the string of clubs in. This is going to pass the string of ace in, and this is going to pass the value of 0 plus 1, which is 1 in. Cool. So we have a deck of cards, which is great. Let's check our prompt.
So in your case, king is going to have a value of 13?
Yes.
So if you wanted ace to have a value of 13, you would just reorder your vowels.
Yep, I would just copy paste this guy right here.
So that is, because in Python, dictionaries are not necessarily ordered, but in that case, ace will always be the 0th element of vowels.
But this isn't a dictionary, this is a
List.
array. Because he created an array.
Oh, that's an array, yeah.
Right, and so an array is always, okay.
Can you go back to your card CS?
Cool. So I'll hold that up there for a second while we talk about this next one. Given the when initializing the deck, make sure there's 52 cards. Give the deck a deal method that selects the topmost card. Cool. So I'll leave that up there. So we're going to need a deal method that draws the very first card, which in my mind is probably like the 0th indexed card of that list, right? So we can do that a handful of different ways. You can just reference it by its like 0th index. If you want to use link, you can do like a dot first, which will just pull the first item in the list. Whatever you guys want. But let's go ahead and create that method. So in our deck.cs, we just need to create a new function or a new method. Public, I think we're supposed to return the card, right? And returns the card, yes. So public card deal. And we are going to store in a card object card equals cards dot first. use link. Cool. So we will remove that card. So cards dot remove at the 0th index and return card. Cool. So first line in the method there, we're just going to select the first card in our list, put it in this card variable that's typed card, remove it from our list, which is to say that it's the 0th index of our list, right? We have this dot remove at method that's very handy, and then we're just going to return the card. Cool. If the prompts, we didn't need to return the card for whatever reason, we could just like discard it, right? Well, a lot of games you'll just discard the card. You don't need to. You don't care what it was. You could just simply maybe change this to void, and you can get rid of this line and get rid of this line, and just straight up cards that remove at 0, right? Cool. So let's check to see if this works. Let's go to our program.cs. I have this myDeck object. So how can I call the deal method? myDeck.deal. Cool. So let's store whatever that returns in a variable. Card dealt card. Cool. So if I were to console.writeLine dealt card, what should we assume would be the first card that we pulled? Yeah. You don't have to do this system.console.writeLine and put a breakpoint there. It was just like it's habit of mine, so that's why I do it. Cool. So our dealt card, which is an ace of clubs. Cool. So successfully retrieving the topmost card, right? So if we were to deal 3 cards, dealt card 1, 2, and I console.log my deck, I should have, what, 49 cards in there? Cool. So if I pause there, take a look at my deck, I should have 49, right? So I dealt in ace of clubs, a 2 of clubs, and a 3 of clubs. What's left in my deck starts from 4 of clubs and onwards. Cool. Nice. Making progress. Give the deck a reset method that resets the card's property to contain the original 52 cards. So this one's pretty simple. I have this build deck function. Just call it reset, which means I can just call reset when I build the deck. Cool. So if, let's say, I dealt a bunch of cards, game over, I can console.writeLine my deck right here, so I'll put a breakpoint right there. I can call my deck.reset now, and then if I were to console.log my deck again, hopefully I'll see a fully reset deck. Cool. So we hit here. My deck has 47 cards. I'll hit my reset method, and then when I hit, oh, that's weird. 99 cards. What'd I do?
You added 52 more cards.
So what do I got to do?
You gotta clear your list.
I got to clear my list. So instead of,
Cards not cleared.
I can do cards not clear. You're right. Just do this. Yeah. Cards not clear would work perfectly fine. Yeah. Cool. So let's try that again. All right. So I have 47 cards because I dealt 5. And then I'll step over into my reset and yay, 52 cards. Perfect. Back to normal. Awesome. So I think the last one is going to be to shuffle my deck. Do we want to see that? It's the same as the shuffle from yesterday. It's just your standard Fisher-Yates shuffle where you're going to take the first card, find a randomly indexed card somewhere in your deck, and then swap them. And then move those forward, too. Cool. All right. Let's do it real quick. Why not? So deck, reset, deal, public, I think it's void, shuffle. Cool. So what do I need? I need a random object. Random, rand equals new random. Need system. And I'll have a for loop that runs through ints I equals 0. I is less than cards dot counts. Yes, it's a list. And I plus. I'll have a random index, which will be an int, which will be rand dot next anywhere from I to cards dot counts. And I can just swap. So I will set a card holder called temp equals cards at I. Cards at I will equal cards at rand index. Cards at rand index will set to the temporary card that we have on hold, and we have a shuffled deck. So we have my deck. We will console.writeLine my deck, but before we do that, let's my deck dot shuffle it up. Cool. So put a breakpoint here and there. Debug. Awesome. Hits it. Check out my deck. Nice order. Ace of clubs, two of clubs. If I step over, hit my shuffle method, and I write line again here, I have a queen of spades, a six of spades, a five of hearts, eight of hearts, nine of diamonds, and so on and so forth. Cool? Awesome. Now, last class here, player. This one's interesting. Let's go ahead and just follow the instructions. Finally, create a class called player. Same thing we've done, just like our card and deck.cs, I will create a new file called player.cs. Make sure it shares the same namespace of blackjack, and we'll have a public class player. It looks like our player needs a name property and a hand property. So public string name and a public list of cards called hand. And what's going on here? Cool. And when we initialize our player, we're going to run a constructor function. Not out here. Public player. We will want to pass in a string called name. We're going to set name equal to, other way around. We're going to set name equal to the name that's passed in, and we're going to set hand equal to a new list of cards. Cool. So now, in our program, we can create a couple of new players. Player, we'll do Donovan. What happened there? equals new player called Donovan. Cool. And then maybe we can console.writeLine Donovan.name. Maybe we can console.log Donovan.hand. Cool. What will we expect to see here?
Hand should be empty.
Hand should be empty. Cool. So step over, we get Donovan here. Step over, Donovan's hand has nothing in it. Count of 0. Just an empty list, right? Cool. So moving back to our prompts, give the player a draw method. This is interesting, of which draws a card from a deck and adds it to the player's hand. So we have a couple of different objects interacting with each other, right? So I have a player object who needs to draw from this deck object and retrieve a card object and put it in its list, right? So it's not as complicated as it seems. Let's just start coding and see what we end up with. So player, here we go. We have public, I think, do we have to return the card? Draws a card, returns the card. So public, card, draw, cool. So if we're going to be drawing from a deck, we need a deck to draw from. Does that logic make sense? So it needs to be passed into this method. So we need to pass in a deck object. We'll just call it deck, right? So now we have this deck object within this method. We can do deck dot deal, right? Because we know that deal delivers one card to us, right? So why not hold this object in a variable real quick? So card dealt card equals deck.deal. So I have this dealt card, right? And let's say I shuffled my deck and I called deck.deal, which means that I'm going to get the topmost card, which is some random card. What do I do with that card? What do I do with this dealt card object?
You want to add it to your hand.
Add it to my hand. Cool. So hand dot add dealt card. And I think the last thing it told me to do is just return the dealt card. So return dealt card. Cool. And that does it. So the interesting thing is when I call that method. So let's say I have let's say I shuffle my deck first. So my deck dot shuffle. Cool. Let's say so we have a couple of players here. Let's say Donovan dot draws from my deck. Cool. Let's say he draws 2 cards from that deck. And let's say Devin, oops, that's all caps. Why did that happen? Devin also draws 2 cards from the same deck. Maybe they alternate. Who knows? So Donovan draws, Devin draws, Donovan draws, Devin draws, right? But the point is that they're drawing from the same deck, so the cards that are in order or shuffled in that deck are being drawn one off the top. Does that make sense? Cool. So let's take a look at a couple things. So my deck up here, and let's do Donovan dot hand here and Devin dot hand here. Cool. So if we debug, the deck gets initialized, the deck gets shuffled, Donovan gets initialized, Devin gets initialized. We take a look at our deck. Hopefully it's a random deck. Cool. There's a queen of diamonds at the top, which means it's shuffled. Then, cool. Donovan draws, Devin draws. Donovan has 1 card. Devin will have 1 card. Then Donovan draws. He's got 2 cards. Then Devin draws. He's got 2 cards. So we can take a look at our deck. Should only have 48 cards. Donovan's got a queen of diamonds. Oh, and a queen of spades. Lucky ladies. Devin's got a nine of diamonds. Eight of diamonds. Ooh. You going for it? Are you calling on the... Okay, cool. Anyway, sorry. So we have... Yeah, you got to see the flop, man. That's a good hand. Yeah. So we have a deal method, which draws a card from a deck and adds to the player's hands. Cool. Give the player a discard method, which discards the card at the specified index from the player's hand and returns this card or null if the index does not exist. Cool. Last method, guys. So our player needs a discard method. So simple enough. Public card discard. Cool. So we're going to need an index to withdraw from. So it's going to be an int called index. And what do I need to do? If I have 4 cards in my hand and someone passes in the number 4, I'm going to guess that they're asking me to remove the 4th card. Right? If I have 2 cards in my hands, those are indexed 0 and 1. But I'm not going to rely on the user to know that they need to discard the 0th index to remove the first card. So in order to account for that, I'm just going to do like index minus minus. Yeah. So now I'm working with actual indexes. So what I need to do now is what's my if check for me returning null?
Your index is greater than your hand size.
Index
Or
is
less
greater.
than 0. Like, I don't know why somebody would pass in the negative number.
Sure, we can count for that too. That's good. I didn't even think about that. If index is greater than hand dot counts. So if I have 4 cards in my hand and a user passes 5, I'm going to check 4. Is 4 greater than... No, yeah, that's good. Yeah, I think that's good. Cool.
You want to do that check before you decrement index.
Do I?
Sure, because your hand count is 4, and if I pass in 5... Oh, well, I guess index is not greater than 4. It's equal to... Never mind.
I think, yeah. If this was greater than or equal to, I think so. But cool. Then return null. Otherwise, I'm going to place in my card discarded card equals hand dot remove at index. What happened here? Oh, I skipped a step. So I'm going to store the card at index of that hand, and then I'm going to hand dot remove at idx, which should remove it, and I will return discarded card. Cool. So let's test this out. Let's say I have a user called Donovan. Donovan draws from my deck 5 times. And let's say Donovan dot discards his 3rd card. Cool. So we will console dot write line Donovan dot and just put a breakpoint here so we know it stops. Debug. Oh wait, shoot. Did I? Okay. Cool. So let's take a look at the card. Hand before and after. So we draw 5 cards. We'll take a look at our hands. Donovan's hand. We're going to eventually remove the 3rd one. So this card right here. So a 10 of diamonds. So 8 spades, 10 diamonds, 9 hearts. Hopefully it goes 8 spades, 9 hearts. So the 10 of diamonds gets removed. Cool. So eight of spades is in the second index, and the 9 of hearts. 10 of diamonds was removed. Cool. And I now have 4 cards. Cool. And that's the assignment. You can totally see that I am just a few steps away from making like a 5-card stud game, right? Of course, the algorithm that you'll have to write to kind of like to evaluate hands. Like, so what if I have a bunch of hands in my or cards in my hand? I have to evaluate whether like a contiguous string or a contiguous flow of like 5, 6, 7, 8, 9 is like a straight or not. You guys will have to write that. But you can see that at least the game flow has been created. You just have to prompt users to like input information for like a hits or a fold or whatever what game you're creating. But yeah, question?
Can you, in your discard, can you do an index that it doesn't exist really quick?
Yeah. And let's do a player. If we do hit this statement, let's do a so that we just see it on our console. So let's .NET run and out of index. Yeah. So maybe we'll try like 6, like just out of index.
Well, 5 would be.
5 would be in our index. Yeah.
Because you only have 5 cards.
His index is minus.
Yeah, I decreased my index by 1, so it makes more sense. Oh,
You don't.
what happened? 6. If index minus minus, so that's at 5 right now. If 5 is greater than 5, oh, greater than or equal to.
What we were talking about.
Yeah.
You were wrong.
There we go. Good to know. Out of index. Cool. Awesome. Any other questions about this particular? Cool.
So why did it just break? Sorry. Say that again.
Sorry?
Why did it just break?
It broke because there was no equal to there. So if I passed in 6 and I currently have 5 cards, I index minus minus, so that brings it down to 5, right? So if 5 is greater than 5, which it's not, right? So it's gonna not hit that if statement. So we just need to do it if.
And then we're going to try to discard the card at index.
Exactly, which is why we got that out of index argument out of range exception. Index was out of range. Yeah.
Could you
Error.
have avoided that by just not minusing index?
If I had avoided that, if I did not do minus minus, then I think I would.
Index would have been
You
greater
have
than
to
0.
remove that index minus 1.
Exactly. Yeah. Yeah, exactly. Cool. So this demo was recorded. I'll put it up on YouTube or something and put it in our Slack channel. Definitely have. I'm going to close this video.